Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is triangles. This is the second video on triangles. In the first video, we saw the difference between congruence and similarity. Then different criteria for proving similarity in triangles were given, like two sides and included angle, we call it as SAS criteria. Then side criteria and the angle criteria. Then a couple of theorems were also discussed. For example, if a line divides two sides of a triangle in the same proportion, then it is parallel to the third side, and vice versa is also true. In this particular video, we will apply all those principles for some extra punch problems. These are examination oriented problems, so be ready with pen and paper. In the first problem, we are seeing a trapezium. If one diagonal of a trapezium divides the other diagonal in the ratio 1:3, prove that one of the parallel side is 3 times the other. So what is a trapezium? Trapezium is a quadrilateral or a four-sided figure with two parallel sides. So here AB is parallel to DC. Then these are the diagonals DB and AC. It is given that the one diagonal divides the other in the ratio 1:3. So from this figure we can say that BE is to ED is equal to 1:3, or in other words D is to EB equal to 3:1. This is given. So what is that we have to prove? We have to prove that one of the parallel side is 3 times the other. That is to prove this side, parallel side, bigger parallel side DC is equal to 3 times EB. So how do we proceed this? We take these two triangles into consideration, ABE and DEC. Then we try to prove that these two are similar. Once they are proven similar, then we can get a relation between DC and AB in terms of the other two sides DE and EB. So let us try to put similarity of these two triangles. So in these two triangles, if we see that this angle is equal to this. That's what we have written here. Vertically opposite angle. So we write it as DEC is equal to BEA. So vertically opposite angles. Similarly, if in a quadrilateral or in a trapezium, we know that AB is parallel to DC and BD is a transversal. So we know that the corresponding angles will be equal. So this angle will be equal to this angle. That's what we have written here. I'm sorry, it is alternate angles. So angle EDC is equal to angle EBA. These are the alternate angles. So by angle criteria, we can say that these two triangles are similar. So once these two triangles are similar, we know that their sides are in the same proportion. So we have to first properly write the similarity in proper order. Since these two angles are there, let us start with this coordinate as D. Let us start with D, then the corresponding point for the other triangle will be B. E is common, so we write it like this: triangle DEC is similar to angle BEA. You cannot write it like triangle DEC similar to triangle EBA. That will be wrong. You have to write in proper order. That is very important. So once we write in proper order, their sides can be written in the same proportion by just seeing the coordinates here. For example, DE by BE will be equal to DC by BA, and EC divided by EA. That's what we have written here. So this notation is very important. DC by AB is equal to DE by EB equal to 3:1, that is given. So from this we can easily get DC will be equal to 3 times AB. So this is what is required to be proved. In next problem we are given a triangle ABC where PQ is a line segment intersecting AB at P and AC at Q such that PQ parallel to BC. PQ is parallel to BC. And it divides the triangle ABC into two equal parts. So this area is same as this area, green color area. So area of triangle APQ is equal to this trapezium PQCB. So this is given, these two areas are given to be equal. That's what area of triangle APQ is equal to area of quadrilateral or trapezium PQCB. Why we are calling trapezium? Because PQ is parallel to BC, it is given. So we write in terms of smaller triangle. So we write this area as the area of the bigger figure minus the area of the smaller figure. So that's what we have written. PQCB, area of PQCB is area of ABC full triangle minus area of APQ the smaller triangle. We take this onto the left side, so we get 2 into area of APQ. Area of APQ is area of triangle ABC. Now we have to get BP by AB. BP by AB. We know that this is cutting this and the corresponding sides have to be in proper ratio. So what is that? We try to prove triangle ABC and triangle APQ to be similar. Once we prove that, we know that the area will be in proportion to their sides. That's what we are trying to prove here. So in triangle ABC and triangle APQ, and triangle ABC, what is the common angle? Angle A is common. Angle A is common. So this is common for both triangles. And what are the corresponding angles? Angle ABC equal to angle APQ. Angle ABC equal to angle APQ. We will also show that also. This angle and this angle, they are same. So they are the corresponding angles since PQ is parallel to BC and AB is the transversal. So these two angles are same. So according to the angle criteria, these two triangle APQ and ABQ are similar, and we have to find relation between areas triangle AB, because this is given to us. So the areas are proportional to the side square. Once you prove that two triangles are similar, please note that the areas will be proportional to the side square, and if perimeter is required, then perimeter will be proportional to the sides. So area of the triangle ABC and APQ is proportional to AB square by AP square. That's what we have given, and that is equal to 2:1 from this identity. Now we invert and take square root, we will get AP by AB equal to 1 over root 2. But what is AP? AP is AB minus BP. That's what we have written, AB minus BP by AB equal to 1 by root 2. So AB can be taken as 1. So 1 minus BP by AB equal to 1 over root 2. We have to keep an eye on what we want, BP by AB. So BP by AB will take right hand side. This will take it here. So it will be 1 minus 1 by root 2, which is root 2 minus 1 by root 2. So the final value of BP by AB is this, root 2 minus 1 by root 2. In this problem, we are already given that the two triangles are similar. So ABC is similar to DEF, it is given. And three lengths of this triangle is given as 4, 2.5 and 3.5 respectively. Similarly, for the other triangle, one of the side is given as 7.5. So we know that if we have to find perimeter of this triangle, then the perimeters are proportional to the sides. So we'll write perimeter of ABC by perimeter of this triangle is proportional to their sides. We'll take this side because this value is given and other two values are not given. So we'll write 2.5 by 7.5. 2.5 by 7. And what is the triangle of ABC perimeter? 4 plus 2.5, 3.5. So how much is this value? 3.5, 4, 6, 10 centimeter. So this will be 1 by 3. So 10 into we cross multiply. So 10 into 3 is equal to perimeter of DEF. So we get perimeter of DEF as 30 centimeter. This is what required for the problem. Now let us take another problem. In this triangle ABC, we see that DE is parallel to BC. This is given. Then we need to find the value of x. So whenever we see that in a triangle, if one side is touching the other two sides, or one line is touching the other two sides and is parallel to the third side, then it divides the two sides in the same proportion. It means x by x plus 1 by x plus 1 is equal to x plus 3 by x plus 5. So we want to determine x. So we cross multiply. So x into x plus 5 equal to x plus 3 into x plus 1. Then we get x square plus 5x. Then we multiply here each term x square plus x plus 3x plus 3. We simplify, we get x as 3. In this particular problem, we are given two triangles ABC and DBC are two right angle triangles with right angle at angle A and right angle at angle D. So angle 1 is equal to angle 4 equal to 90 degrees. It is given. Now we want to prove that the sides AP into PC is equal to BP into PD. Whenever such problems are given where we have to prove that some sides are coming into the picture, then we must try to make two triangles containing these sides to be similar. Once we prove that the two triangles are similar, then the corresponding sides will be in the same proportion. This is what we are trying to do. So let us see these sides AP and BP. So this corresponds to this triangle. And the other triangle is corresponding to this, where we have the sides PD and PC. So these all four sides come into picture if we can prove these two triangles to be similar. So let us prove that. So in the first case, angle 1 is equal to angle 4, angle 1 equal to angle 4, this is given, right angle it is given. Similarly, angle 2 will be equal to angle 3, angle 2 equal to angle 3, vertically opposite angles. So by AA criteria, these two triangles marked with red and green color are similar. So once they are similar, their sides are in the same proportion. So the sides are BP by PC is equal to AP by AD, AP by PD. So that's what we have written here. And when we cross multiply, we get what we require. So the idea of the whole problem is, first we must see what we have to prove, then bring those sides into corresponding triangles, which we then try to prove to be similar. Once you prove that they are similar, their sides will be in proportion and we will get the final result. Now in this particular problem, triangle ABC, D divides CA in the ratio 4:3. We see that this is bigger side, so we'll call it as 4k, or it can be 4x, and this one is 3k or 3x. Now it is given that DE is parallel to BC. DE is parallel to BC. Then find the area of BCDE to triangle ABC. We want to find the ratio of these two areas. So now we see that in triangle ADE, and in triangle ACB, the smaller triangle and the bigger triangle. Now we are trying to make it similar. So we see that angle 1 is common and angle 2 is equal to angle 3, because D is parallel to BC, so they are the corresponding angles. AB is the transversal. So we see that the smaller triangle AED is similar to angle ABC. Now once the triangles are similar, their areas are proportional to the side square. We know that. So area of triangle AD, smaller triangle, to the bigger triangle ACB is equal to proportional to the side square. So AD square is given as 3k or 3x, we call it 9, and AC square will be 4 plus 3, 7 square, so it will be 49. We call it as some ratio 9x to 49x. Now we see that since we want this trapezium area DEBC, so we call it as 49x, which is the whole triangle area, 49x minus 9x, the small triangle, so it will be 40x. So area of trapezium will be 40x, and that too for the whole triangle it will be 49x. So this what ratio we require: area of quadrilateral BCD or trapezium BCD divided by area of triangle ACB. This. So the ratio will be 40x by 49x, which will be equal to 40 by 49. In this particular problem, we see that we are given the ratio PS by SQ is equal to PT by TR. Then once this side ratios are equal, sides are in proportion, then we immediately it should come into our mind that ST is parallel to QR. This is by theorem. This is what immediately we should write: ST is parallel to QR, since the sides are in the same proportion. So now it is given that this angle R or angle PRQ is equal to angle PST. These two angles are equal. It is given here. Let us write it as this as sum x, and this also sum x, this also x. Now we see that since ST is parallel to QR, this angle and this angle will be same. Why they will be same? Because it corresponds to the corresponding angle. So this angle will be x. So this angle and this angle will be same. We write mathematically as angle PST is equal to angle PQR, both equal to x, and angle PST and angle PRQ is also given as x. So hence we can say that angle PQR, this x, will be equal to PRQ. Both are x. So in the triangle, if two angles are same, then their opposite sides are equal. So we know that this side will be equal to this side, so we can write PQ is equal to PR. So hence PQR is an isosceles triangle. Since in an isosceles triangle, two sides are equal. Let us take another problem. This is very interesting problem. In this we are given a square ABCD, and we are putting two equilateral triangles on one on the side and another on its diagonal. So let us take one side of the square ABCD, AB being the one side of the triangle, equilateral triangle. So the corresponding sides are ABE. So this is an equilateral triangle. ABE is an equilateral triangle. Let us highlight this. This triangle is an equilateral triangle. That's what we are trying to highlight. Then we take another triangle. Equilateral triangle with diagonal as the side. So here diagonal DB is taken as the side, and now we have to prove that the area of triangle ABE, area of triangle ABE area of triangle ABE and this triangle DBF. We want to find relation between these two. This triangle marked with green color and this with the blue color. We want to find their area. Let us, in some ratio, let us find that. Now by AA criteria we see that these two triangles ABE and DBF are similar. Why they are similar? First of all their three sides are equal. So by side criteria itself they can be equal. Further, all their three angles also equal because it is an equilateral triangle. So by AA criteria also AB is similar to DBF. So we can write that the areas are proportional to side square. That's what we have written here. Area of triangle ABE to area of triangle DBF is proportional to the side square. AB square by DB square. Let us put AB as X. So what is DB? DB is the diagonal. So diagonal can be written as X square plus X square, which is 2X square. So we write it as area of triangle ABE by area of triangle DBF. So AB square will be X square and DB square will be 2X square. So X square will get cancelled. So we will get 1:2. So this triangle to this triangle area ratio is 1:2. Let us take another interesting problem here. In this particular figure, angle 1 is given to angle 2 and angle 3 is given to angle 4. We want to show that PT into QR into PRST are this particular multiplication of side is equal. So how do we proceed? Again we see that this particular sides like PTST, they correspond to a particular triangle, this PST, and the other ratio corresponds to this triangle PQR. So if we try to prove that they are similar, then their sides will be in the same proportion. So we see that first that angle 3 is equal to angle 4 in those two triangles PST and PQR. This is given. Then angle 1 is equal to angle 2. This is also given. Now we add angle 5 to both. Now angle 1 plus angle 5 becomes SPT. And what is angle 2 plus 5? RPQ. So hence we see that by A criteria these two triangles are similar. Once they are similar, their sides will be in the same proportion. So we write, since they are in proper order, we can write PT by PR equal to ST by QR. Cross multiplying, we get the desired results. With this problem, we conclude this video, friends. I request you to please subscribe my channel and give a thumbs up to this particular video so that I get motivated to make more such good videos for you. Thank you very much, friends.